Hello, my name is Saljug Mammadli, and this is my video for the project for my Physics 101 laboratory. In my project, I have discussed how to determine the coefficient of static friction at different surfaces, and I've also investigated the impact of the mass of an object on the coefficient of static friction. In order to understand my experiment, I will first show you the free body diagram of the setup of my object. In my setup, I will have an inclined plane, and on this inclined plane, I will put a block. I will gradually start by increasing the angle, as you can see here, and I will increase the angle slowly until I can see the block just move, like a bit before it moves. And then I will record that angle, which will be my critical angle for this experiment. You may ask, why do I need to find this angle? And for that, I would have to explain how I will use this angle in order to find the coefficient of static friction between the block I have and the surface plane. As you can see, when we take this weight and we divide it into its parallel and perpendicular components, we can see that this and this will cancel each other out. The normal force and the weight times the cosine of this angle will cancel each other out, and the frictional force will be equal to this parallel component of this weight. Using a bit of geometrical equations, we can find that we will be needing only tangent of the angle in order to find the coefficient of static friction. We came up to this conclusion after writing the formula of the frictional force and then simplifying it to get this. As you can see, this was the setup for my experiment. In this experiment, I have an inclined plane and I put the block on it, and I have a friend who's holding a protractor. I'm slowly rising the angle of the incline, and as you can see from here, we can see how many degrees it is on the protractor, and we record this critical angle. As you can see in this setup, we're using multiple blocks that have different masses, and as you can see from their surfaces, they have been sanded a bit differently, which will yield minimal amount of error, because they do have, even though they're the same material, they do have a bit slightly different coefficient of static friction due to different sanding methods. So this is our setup with metal. We are using metal material in order to change the coefficient of static friction of the whole thing, and we are also changing the mass of it in order to vary it for our experiment. Overall, you can see the result of our experiment here. As you can see, we have recorded tables where we have varied masses, and on each table we're using different materials in order to vary the coefficient of static friction. We have found critical angle for each trial, and then we have found the coefficient of static friction using the formula that I've showed before. And then we have found the average of it. We have also drew the graphs of these, and theoretically, as you know, it should be a straight line. There is a very minor slope in all of these graphs, which happens due to like very minimal error. So overall, these graphs do show that mass does not affect the static coefficient of friction, only the material of it does. And we have shown you how to find it here in this video.